Yes, still on the same bridge. When you have done your modeling, you have applied the loads. The application of loads, I forgot, you need to know there is vertical pressure, you have lateral pressure due to soil, you also have hydrostatic pressure, you have live load surcharge behind the abutment, and then now then you go to also define the lane which you are going to instruct or to guide the vehicle to move. And you have to make sure you divide the lane. If it is the areas actually here, this is where you always come for the moving load. For this case, you have to come in here and then you specify your lane. Like if I'm adding, so here is where you have all the requirement that you need to do. So once it is done, you are now, then you come and define the vehicle. These vehicles are very, very important that you need to know. They are all here. You have to make sure if it is load model 1, these factors are very important. They are all in the code and the manual. You need to make sure they are there. The tandem system are all given here. Follow this exactly where it's supposed to be. If there is a footway, you indicate the footway. It will give you all that. For fatigue, but concrete, normally we don't go into fatigue too much, but fatigue, you have to make sure you come also specify what model you are applying. Make sure you indicate that. And then railway, this is not a railway stuff. That is what you need to do. So this is as brief as it is. Then we run into analysis. Now, when you go to analysis, then you are able now to review, to view, um, I want to remove this, I want to remove the lane which had indicated. So if I go to analysis, the results I can now view, maybe soil pressure I can view from due to date load. I'm able to see soil pressure and then this is on plan. This how pressure. So now this soil pressure value should be either equal or less than the bearing capacity. In this case, about 117. So if your bearing capacity is 200, then you know you're not doing very badly. So then I can now also go and look at other effects, even temperature. I want you to look at the temperature effect. Temperature effect here, you can see that temperature also has effect on foundation, and yet you want to apply it where? On the deck. So this is how you can view your, so for the plate, you can also look at the plate forces, and then there was a section already cut, which I would just like to make sure you appreciate. This is how you look at your your output. This is a dead load. Then I always also look at, then you can look at the combined, okay, for the vehicle alone, that's how it will look like. And then I'm able to demonstrate to you how you can actually quickly look at your, so this is your analysis output, and then you are able to do this. Is simply supported, but because the bearing is slightly in, then you have a hogging effect. There's a bit of like simulated to be a cantilever because the bearing is a 0.44 meters off the end of the girder. So you can look at this behavior, you look at the abutment, look at the foundation. This is exactly what you will be looking at, and then when you are doing your stuff. Basically, that is what you do, but then that's the output you get. Even settlement has implication. Settlement also has, and you specify this how settlement affect the foundation. No, there will be a change in the stress response of the structure. If you allow it to settle by maybe 10 millimeter, 15 millimeter, so it's important we take care of that. So this is the analysis output that you always have to make sure you look at carefully. In most cases, for soil pressure, also here lateral pressure, you can also have a look at. This is how the lateral pressure affect. You can see how high you have that. the vertical wall takes a lot of the stresses. So basically, that is as brief as